Welcome guys to another video from DataSolve, and in today's video we are going to be jumping into those annoying interview questions, those pet trick questions that stop you from landing that dream job. So in today's video we're going to go through 10 or 11 of my favorite interview questions, and we want you to get that job, that data analyst job, data engineer, SQL developer job, whatever it is, we're going to get the job for you. So keep watching this video and hope you enjoy. Alright guys, so I hope you have your coffee, tea or preferred beverage of choice as we jump into today's video. The number one question you may receive in an interview is, what type of joins do you know? I'm going to preface this with saying we are using SQL Server syntax, so I apologize for anyone else who is not of the SQL Server syntax family. So having said that, what type of joins do you know? The answer, inner join. Returns only the intersection of two tables. So the syntax would be select all from table A, inner join table B on b.id equals a.id. And this would return the intersection between two tables where there is commonality. And it would omit any records that do not exist in those two tables. Left outer join, or better known as left join, will return all records from the left table and those records from the right table that satisfy a defined join condition. But most of the time you join on an ID, and if there is no commonality in the second table, in table B, it will return a null value for that. It's basically the same thing, but it takes the precedence of the second table. So returns all records from the right table and those records from the left table that satisfy a defined join condition. And then we have lastly the full join or full outer join, returns all records from both or all tables. It can be considered a combination of left and right joins. Question number 2, what is an index? So an index is a special data structure related to a database table and used for storing its important parts and enabling fast data search and retrieval. Indexes are especially efficient for large databases where they significantly enhance query performance. So you can think of an index as a way to enhance query performance and also database performance. Question number 3, what type of indexes do you know? So there are many indexes. This is just a test, basically. We just want to know. So to answer the question, what type of indexes do you know? The three main would be the unique index, which holds data integrity. It does not allow duplicate values in that column, in a table column. Clustered index defines the physical order of records of a database table and performs data searching based on key values. So clustered index is used on the primary key values, and a table can only have one clustered index. And probably the most popular is the non-clustered index. Keep a memory of that. And a table can have multiple non-clustered indexes, and it is usually placed on the non-key attributed column. Now, I just want a side note on this, and I think this is very important that you get a fundamental understanding of performance. I'm going to give you a quick demonstration, and this is by no means a proper course in performance tuning. This is just a demonstration. I've got some test scripts and you can copy these. I've provided this they should be in the description. So if we create this table and insert there, we can see 17,000 rows. And now what we want to do is we're going to use these set statistics commands, so time and IO. And what these will do is this will check the time of execution, how long it took to execute the query, and also will check the logical reads and physical reads and other metrics. So the less reads, the better, the more reads, the worse. That's rule of thumb. So let's run. Okay, so this, obviously it's a quick query. There's only 21 rows here, but this took one millisecond to run. There was 86 logical reads. This is a copy and paste I did previous, so we can see 86 logical reads. When we place the non-clustered index on the product ID, if we run this query again, less logical reads, and we can also see that the server execution time is actually 0 now. When we talk about performance, this is a very crude demonstration of what performance is. But that's effectively it for those two questions. And question number 4, what is normalization in SQL and why use it? Normalization is the process of, restructuring data and reducing data redundancy, duplication and inconsistency, leading to enhanced data integrity. Having known that, you can be in 1NF, 2NF, or 3NF. Won't go too much into detail. You can watch my video where I go into detail about if you would like to. What is denormalization in SQL and why use it? Denormalization is the process opposite of normalization. So denormalization is used primarily in the dimensional model. So when we bring primarily used in ETL loads and data warehouses where the end user needs to query a database, they are querying the denormalized database, the dimensional model. So it would be consisting of dimension tables, fact tables in a snowflake or star schema. There is less overhead or less strain on the engine in a denormalized state because there are less joins. There are more columns, but less joins. So in theory, we state that the denormalized database in SQL is more efficient. What are the differences between sum amount and sum amount over partition by product, order by date, ascending? The answer would be, so the difference between the sum amount and sum amount over is that sum amount reduces the number of rows to 1 per group, whereas the sum amount over, that over command with the partition, is returning a value for each row based on the define window. And it's very important that you understand the difference. I should have a diagram up of what that looks like so you can visualize that. How would you write a query to calculate cumulative sales over the sales date? Would we use the over or we would just use the sum? So in this case, the cumulative, we can write the query like this. So sum amount over sale order by sale date from sales. So this is the accumulation in each subsequent row. We have the aggregated, the cumulative value, and this is how we would write a cumulative query. Please note that you wouldn't put that partition. That partition command is only useful when we want to return a value for each row based on the define window. So we're not working with the define window. Basically, we're working with everything here. So we wouldn't need that partition clause. All right, cool. So on to the next question. So given a table with a sequence or auto increment primary key in a value field, delete the newest records from the table for records that have duplicate values. All right, so what the question is asking is that there are row 2 and 3 are duplicates of the value. So the value is there. So what we want to do is we want to remove these 3 and 5 and retain the 1. How would we do so? And there are probably multiple ways to do this, but I think that for self-practice, there's a solution that we can use a self-join. So if you want to give this a shot, I've got the script down below. You can copy and paste that script into your database engine and you can give it a shot. I'll give you some time. All right, so let's go over the solution now. So what we want to do is the solution, we can use a self-join for this solution. So we select all from table A, inner join. Now, why would we use a self-join? So let's just kind of step back a little bit. So there's one reason and you can use the row number function, but in this case, we've opted to use the self-join. So the reason we use the self-join is we want to find duplicates. Obviously, if we run this command, it's going to cause a Cartesian join, which is not what we want because we want to delete only the values that have been recently inserted. Now, the only way we can differentiate is we know that those values are higher. The ID number is higher. So we want to find those that are higher. B. So this is where we can compare with a self-join in the condition clause. You can compare an operator to another operator effectively. So we want to find that which is higher. All right. So we're selecting all from table A and then all from table B. And we want to only pull back where B is greater than A. So as we can see here, these are the three values here. And there is a duplicate in here, but we don't need to worry about that. Still, we haven't pinpointed, the solution is still not valid. What we need to do is we need to add a where clause where a.id in select min id from table. So now this is where we're cooking with gas. So this is where we are only pulling back. So this where clause is very important because it specifies that A can only be the minimum value. So B is always going to be the maximum or the higher level value. And in this case, we have 2, which is 3 and 5. And then what we want to do is we just want to refactor this, delete from my table, delete from there where ID is in this query. 2 rows affected. So if I do this, there should be no duplicates. These are the freshest IDs effectively. And this is using a self join to detect the duplicates. And we're using this condition here. And we're using a where clause as well to help assist this self join clause. So that's a good pattern that you should memorize. It's a very rare pattern. Like you may use it in real life. I'm not sure, but it's something that will definitely will be quizzed on this in an interview on a difficult question, I guess. So that's it for that one. Here we have question 9, and in this question we want to write SQL such that we label each node as leaf, inner, or root node, such that for the node above we get this. So now there are a few different ways that we can develop this solution. In this case, I recommend you using a recursive CTE, create a hierarchy. The reason I say that is because this is a very valuable piece of information that you will most definitely use in your career as a data analyst, engineer, developer, because a recursive CTA has multiple use cases. In this case, we can use it to build a hierarchy and then structure the query that way. There are other ways, and if you want to do it another way, feel free. So I'll give you some, you can pause the video now and have a shot at this. We'll just set up our tables. So select all from hierarchy. So here we are. So what we're going to do is we're going to create a recursive CTE to provide the solution for this. So what is the syntax? How do we get started? So with the recursive CTE, we need to start with the anchor. So the anchor meaning where the node has no parent. So basically the top of the hierarchy, effectively, where parent is null. So this will select the node. So that's the anchor. Then we need to create, sorry, my mistake. We need to actually with CTE as create the structure there. So union all, you need the union there. And then we need the recursive member. This is where we will create the recursion. We'll just fix this up. Parent, and then we need level 0 as level. And this is important to create that hierarchy. The depth, the column, these are the columns here. Union all, select, node, parent 0, level +1 from hierarchy. Just make it look the same. So this will give us that. This is again, this is the recursive member, and this is the anchor. So this is where all the recursion will happen. So in this, so then what we need to do is inner join CTE on C dot. So we want to join on the node because we obviously don't have a parent in here, equaling to the, put that A dot parent. So let's kind of just step back a little bit. And this is the part that kind of confuses me about recursive CTEs. So let's kind of understand what's happening here at the granular. So when we perform the first level of iteration, the anchor returns the root node, node equals 5, parent equals null, level 0. Cool. The recursive part joins t.parent equals 5 from the anchor step with the nodes in the original table. This finds nodes 2 and 3 whose parent is 5 and assigns them level 1. So then once it connects into that first level, it keeps going until you specify otherwise. So it's pretty intelligent how it keeps going in that regard. And I guess this line here is what you need to understand, and this union all. And then the next step would be to complete the question. So if we go select all from CTE, we'll see what that brings up. Cool. So as you can see here, that's the answer. And we were able to achieve that with a recursive CTE. Didn't use a CTE. You can use just a complex case statement. Can use a case statement here to do the same thing. All right, guys, I've saved the most difficult question for last. And this is a rip off the lead code question because I thought the solution was really cool. So let's jump into this one. Question 10, finding sequences. Given a table with people, count per visits, date, find sequences of at least 3 consecutive rows where the people count is greater than or equal to 100. Sounds straightforward, but if you haven't worked with sequences before and identifying sequences, it's not. So let's break this down. So here is the expected input and here is the expected output. So what's the reasoning behind this expected output? The 4 rows with IDs 5, 6, 7, and 8 have consecutive IDs and each of them have greater than or equal to 100 people attended. Note that row 8 was included even though the visit date was not the next day after row 7. The rows with IDs 2 and 3 are not included because we need at least 3 consecutive IDs. I'll give you a bit of time to digest that. Rewind the video if you want to read the question again. But what we can say with this expected output is that the 4 rows with IDs 5, 6, 7, and 8 have consecutive IDs and each of them have greater than or equal to 100 people attended. Let's just put a check here, X. As you can see here, for the expected input, obviously we're not taking this value. We may take this value, we may take this value, but when we see ID number 4, that it's not 100, it doesn't create a sequence, therefore it invalidates the previous records. So then we continue to 145 and the next subsequent values, which are a chain of 4. So we must take in all these values because they have a sequence of 3 or more. Hence, this is the expected output. Now, it's irrelevant the day. The day is not relevant. The ID is sequential. We don't really need to worry about the ID or date for now. We just need a way. We need a way to be able to calculate a sequence within a given data set. Now, all right, what I'll do is I already know the solution. But if you want to give yourself some time to try and figure out this solution, I do implore you. The thing with LeetCode is that it does provide use cases that you need to satisfy. So if your solution satisfies this, it must also satisfy another use case. We'll go through that a little bit later. But we'll start writing the solution now. So put in the dummy data. So I've put in that. So effectively, what we need is a way, is a column to track these sequences. So select all from, so we'll start with a CTE. CTE as select all from stadium, where people greater than or equal to 100. Okay, so what we want is we want to just work on, we want to just start small, and we're working with people that are greater than 100, greater than or equal to 100. So this will eliminate any records that don't need to be here from the get-go. We need a way to identify missing IDs in this sequence. Now, this is probably where the ingenious part comes in. So what we would do is ID minus row number over order by visit date. Now what this is doing, this line here is very important to understand, this ID minus row number. And what this is doing is it's basically grouping by sequences, and if there's a missing gap in the sequence, it increments that to the next level. Hope that makes sense. And this is going to be important in the later part of this solution, because we need to be able to identify gaps in the sequences. So this is the CTE. So then the final outer query would be something like select all from CTE. All right, so this is the final solution here. So this will give us everything, the query that we're after. So just for demonstration purposes, I've put in this row number column because this is the identifier for the sequence. So if it's 3 or more, we include all the values in that sequence. And I think if you understand this, how to identify sequences in a data set, very powerful tool, very powerful ideology or algorithm to understand, and it'll be definitely talked about in your interviews. All right, guys, so that's been the last question, and hopefully this has made sense. This has helped you. Depending on how popular this is, I might make another one, but this is effectively questions that you may be asked in an interview. Hopefully it's provided some value. Please leave a comment, share, subscribe. Thanks, guys, for watching, and I'll see you next time.